Oxidation reduction. What I'm going to do with this? Oh my god, I have to find out the oxidation number. Hydrogen, carbon, other atoms will also come. This is nightmare sometimes, You're thinking like that. No need to think, because you don't need to remember everything. To find out oxidation number, you just need to remember few certain things, and the first thing is that the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. So this is actually the oxidation number. So suppose if you have one reaction or something, then one compound is formed. So for that particular compound, the elements, some elements will release electron, some elements will take those electrons. So the number of electrons they are taking and releasing, depending on that, their oxidation number will matter. Now let's start with the rules of oxidation number. But first, welcome to our channel Simple Physics and Chemistry. So the first rule, the oxidation number of a free element is taken as 0. So if you have some free element like iron, copper, oxygen and nitrogen and so on, so in their free form they are neutral, and thus their oxidation number is also 0. Now if you have monoatomic ion, so for a monoatomic ion in an ionic compound, the oxidation number is equal to the charge of that ion. So suppose you have NaCl. Okay, so sodium chloride. Here sodium has +1 and chlorine has -1. These are the oxidation number. Now sodium releases one electron easily and become a positively charged ion, and chlorine does the other opposite thing, that it can take one electron easily and become a negative ion. So it depending on their charge. Now if you have a polyatomic ion, then the sum of the oxidation numbers of all the atoms present is the total charge of the ion. So what does that mean? And then you can find that the total charge of the ions, if you calculate them, you will find it will be -4. Going to the next, the algebraic sum of all the oxidation numbers of a molecule is 0. So if for a molecule they are neutral, and for that if you sum up all the oxidation numbers, that is for iron chloride, you can see that if he has +2, chlorine has -1, but there are 2 atoms, so as a total it will be 0. Again, the oxidation number of hydrogen in metallic hydride is -1. This is an exceptional case. In general, hydrogen is metallic, shows like a metallic system. It's in its compound and it has +1 oxidation state. Now suppose you have a sodium hydride, NaH. So in there, sodium will always be +1 in their oxidation state, because it can easily release one electron. But in this case, oxygen can take one electron and become negatively charged, and thus here the oxidation number of hydrogen can be -1. And this is the general formula, that that hydrogen will always have +1 oxidation number in other compounds, like you can take as HCl, where hydrogen is +1 and chlorine the oxidation number is -1. Now for oxygen, apart from the peroxides and superoxides, the oxidation number is -2. So first we will see the normal thing, that is H2O or water. Here hydrogen is +1, the oxidation state, and oxygen has -2. This is the usual case. Now for exception, in hydrogen peroxide H2O2, hydrogen is +1, but here if you see, you neutralize the whole molecule, oxygen will be -1. And similarly in the F2O, this is one superoxides. Here fluorine will always have -1, it can release electron, its electronegativity is very high, and thus oxygen will be +2 here. If you consider the halogens, that is chlorine, fluorine, bromine, iodine, okay, so for them their oxidation number is -1. Like in NaCl, HF and HBr, you can see that for chlorine, respectively for chlorine, fluorine and bromine, all of them, the oxidation number is -1. And one special relation, if you want to remember, that the oxidation number cannot exceed the group number of an element. So how does that mean? I'll show in the periodic table. So now we are in the periodic table. So if you see in the hydrogen, it has -1 and +1. I think the whole periodic I have covered, so everything is very small here. If you make your display full screen, maybe it will be visible to you in a better way. Now this one is group 1, there is hydrogen, lithium, sodium, okay, potassium, rubidium, cesium. So next it has group 2, it is group 2, where you can see that the oxidation number, which is written in the bottom of this, you see the beryllium, the oxidation number is written here. For magnesium, calcium, all they have their oxidation number 2. Now let's see some transition metal, like I am going to manganese. For manganese, you can see it is in the 7th group, so it cannot exceed 7, and therefore manganese has so many oxidation number. You can this oxidation number can be seen here. You can see its oxidation number, that's up to 7. So manganese has almost all of the values. This is a very special element, And for iron, you can see this group 8, but it goes up to 3, but for manganese it goes up to 7. This is limit, up to its limitation. So you can find in other also, like all of them, they have, most of them are very defined, the oxidation number, but for some elements they can like react in different manner with the other compounds, so thus they have different type of oxidation, different values of oxidation number. Okay, so this is for a very general review on that, on the oxidation number. If you want to know in detail, so comment on our video, so we'll go through in detail and we'll do the numericals also later. So thank you. Please hit the like button if you liked it, share if you feel it can help others, subscribe to get new videos. Thank you and keep watching.